If log 3 to the base 10 is equal to 0.4771 and log 5 to the base 10 is 0.6990, find log 15 to the base 10. Okay, so our solution, we are going to have log 15 to the base 10 written as log 5 by 3 to the base 10. And this one, by the law of multiplication, becomes log 5 to the base 10 plus log 3 to the base 10. And we have the values for log 5 to the base 10 and log 3 to the base 10. So we substitute. So log 5 to the base 10 here gives us 0.6990. And then log 3 to the base 10 gives us 0.4771. And this gives us 1.1761 as our answer. The second example, log to the base 10 of a fraction with numerator 5 and denominator 3. So we are going to apply the law of division. So we get log to the base 10 of 5 minus log to the base 10 of 3. And we substitute the values 0.6990 minus 0.4771, and that gives us 0.2219. Now let's quickly look at the third example. Our third example, log to the base 10 of 9, and this one can be written as log to the base 10 of 3 to the power 2, which gives us 2 log to the base 10 of 3, and then we do our substitution, which is 2 multiplying 0.4771, and that gives us 0.9542. The fourth example, we have log 25. So this one, the base was not written, which means that it is in base 10. And this one will be written as log 5 to the base to the power 2. So 2 log 5. And that means we are multiplying 2 by 0.6990. And this gives us 1.398. Okay. We take our next set of examples. If log 2 to the base 10 is equal to 0.3010, we have to find the first one, that is log to the base 10 of 8. Our first example, and we can write this as log to the base 10 of 2 to the power 3, which becomes 3 multiplying log 2 to the base 10. So we substitute 0.3010, and that gives us 0.903. as the solution to the first example. The second example, we have log of a fraction with numerator 1 and denominator 16 to the base 10. And we will rewrite this as log of a fraction with numerator 1 and denominator 2 to the power 4 base 10. So this gives us log of 2 to the power negative 4 to the base 10, which we will write as negative 4 log 2 to the base 10. And that gives us negative 1.204. Now the third example, we have, I think I jumped the second one for the third. So this one is rather the third example, and we are now doing the second example. Okay. So the second example is log to the base 10 of root 2. This one you will rewrite as log to the base 10 of 2 to the power 1 over 2. And that can be written as 1 over 2 log 2 to the base 10. So half multiplying 0.3010, and this gives us 0.1505. Okay, so let's go and then work on our last example. We have log, let me use a different color. We have log to the base 10 of 32, which we can rewrite as log to the base 10 of 2 to the power 5. So 5 log 2 to the base 10, and that is 5 multiplying 0.3010, which gives us 1.505. Given that log 5 to the base 3 is equal to 1.465, evaluate without using tables log 25 to the base 3 plus log 15 to the base 3. Our solution. We have the expression log to the base 3 of 25 plus log to the base 3 of 15. So we are going to rewrite 25 as 5 to the power 2. So we have log to the base 3 of 5 to the power 2. We are adding it to log to the base 3 of 5 times 3. And this becomes 2 log 5 to the base 3 plus log 5 base 3 plus log 3 base 3. So here we can rewrite this as 3 log 5 to the base 3 plus 1. And then we know log 5 to the base 3 to be 1.465. So in place of log 5 to the base 3, we are going to substitute 1.465. So this gives us 3 multiplying 1.465 plus 1. We get 4.3 plus 1, and that gives us 5.395 as our answer. Given that log p is equal to x and log q is equal to y, express log of a fraction with numerator pq and denominator 100 in terms of x and y. Okay, so we solve. Solution. We have log p to be equal to x. Now let's convert this to indices, remembering that the log is to the base 10, and so p is equal to the base 10 to the power x. And then we have log q is equal to y. So when we convert this one to indices, we will have q is equal to 10 to the power y. Now, given the expression log pq over 100, we replace p with 10 to the power x and then q with 10 to the power y. That gives us log of a fraction with numerator 10 to the power x multiplying 10 to the power y, and then divided by 100. We can rewrite it as log of a fraction with numerator 10 to the power x plus y and denominator 10 to the power 2. So by the law of division, this becomes log 10 to the power x plus y minus log 10 to the power 2. Then the exponents will be dropped to x plus y log 10 is equal, minus 2 log 10. Remember that the base is 10 and the log number is also 10. So if the log value is 10 and the base is also 10, then they go to 1. So this becomes x plus y minus 2, and that is the expression obtained as required. Without using calculator, evaluate the following. 1. Log to the base 10 of 1000. 2. 2 times log to the base 10 of the square root of 1000. And 3. 16 times log to the base 10 of 1000 to the power a fraction with numerator 3 and denominator 4. Okay, so let's go ahead and evaluate. So we have the first one, log to the base 10 of 1000. We can rewrite this as log to the base 10 of 10 to the power 3. And by our third law, we can rewrite this as 3 times log to the base 10 of 10. And by the properties we looked at, log to the base 10 of 10 will become 1, which gives us 3 times 1, and that is equal to 3. So when we evaluate log to the base 10 of 1000, we get the result to be 3. The second example, 2 times log to the base 10 of the square root of 1000. We can rewrite this as log to the base 10 of the square root of 1000 raised to the power 2. Okay, so as we can see we can cancel out the square root with the square, and that will give us log to the base 10 of 1000. And as we saw in the first example, we will have it as, and then the 3 drops to give us this, which also gives us 3 times 1, which is equal to 3. So this is what we have for our second example. The third one, we have 16 times log to the base 10 of 1000 to the power a fraction with numerator 3 and denominator 4. Okay, so this one, we can also rewrite it as log to the base 10 of 1000 to the power 3 over 4, and then everything to the power 16. So we can have it as log to the base 10 of, so 4 goes into 16 4 times. So 4 will multiply 3, that will give us 1000 to the power 12. And this we can rewrite as log to the base 10 of 10 to the power 3 and then to the power 12, like this. That gives us log to the base 10 of 10 to the power 36. So we have 36 log 10 base 10, and that will give us 36. So that's what we have. Now we continue with the evaluation. Our first one here is log to the base 3 of 81. We are subtracting log to the base 3 of 27 from it. Okay, so if the log bases are 3 each, then let's see if we can convert 81 to 3 to the power something. So we can write as log of 3 to the power 4, and then the base is 3. And then this one, log to the base 3 of 3 to the power 3. Okay, so this one becomes 4 log to the base 3 of 3 minus 3 log to the base 3 of 3. So as we remember the properties, 4 times 1 minus 3 times 1. That will give us 4 minus 3, which is 1. So that is it for our first example. The second example, we have log to the base 2 of 16, and we are adding that to log to the base 2 of 8. Okay, so log to the base 2 of 16 can be written as log to the base 2 of 2 to the power 4 plus log to the base 2 of 2 to the power 3. So this becomes 4 log 2 to the base 2 plus 3 log 2 to the base 2. And as we have already seen, we get 4 times 1 plus 3 times 1, which is 4 plus 3. That gives us 7. So these are the first two examples. Now the third example. You have log to the base 5 of 125 plus log to the base 5 of 25. So we have log to the base 5 of 5 to the power 3 plus log to the base 5 of 5 to the power 2. So we get 3 log to the base 5 of 5 plus 2 log to the base 5 of 5. This gives us 3 plus 2, which is 5. Our next set of examples, the first one we have 2 log to the base 3 of 1 over 9 minus log to the base 3 of 27. Now this gives us 2 log 1 over 3 to the power 2 to the base 3 minus log to the base 3 of 3 to the power 3. So this gives us 2 log 3 to the power minus 2, and the base is 3, minus log to the base 3 of 3 to the power 3. And then now we are going to drop the exponent, negative 4 here, multiplying log to the base 3 of 3 minus 3 multiplying log to the base 3 of 3. So this gives us negative 4 times 1 minus 3 times 1. So we have negative 4 minus 3, which is negative 7. The second one, we have it as 3, 3 log to the base 4 of 16 plus log to the base 4 of a fraction with numerator 1 and denominator 64. So we simplify here, we will get 3 log 4 to the power 2 base 4 plus log 1 over 4 to the power 3 to the base 4. And this one we will have 3 log 4 to the power 2 base 4 plus log to the base 4 of 4 to the power negative 3. So now we drop the exponent, that gives us 6 log 4 to the base 4 minus 3 log 4 to the base 4. So this becomes 6 times 1 minus 3 times 1, which is 6 minus 3, which is 3, as our third example. Then, as our second example, the third example, we have log of 1 on 36 base 6. We are subtracting log to the base 6 of 1 on 216. So here, we try to simplify. So we can write as log to the power, log to the base 6 of 6 to the power negative 2 minus log to the base 6 of 6 to the power negative 3. I believe you understand this. From what we have done so far, I think we understand this step. So we get negative 2 log 6 to the base 6, so plus 3 log 6 to the base 6. This gives us minus 2 times 1 plus 3 times 1, which gives us minus 2 plus 3, which is equal to 1. So that is it for our next set of examples. Without using tables, simplify the expression in fraction with numerator log 81 base x and denominator log 3 base x. Okay, so let's simplify. So log 81 base x divided by log 3 also base x. So what we have, we are going to rewrite as log 3 to the power 4 base x divided by log 3 base x. And this gives us 4 multiplying log 3 base x divided by log 3 base x. So as you can see, log 3 base x is capable of cancelling out. So like this, then our result will be 4 as our final answer. The next one we have, so let me write a solution. Log 32 base 2 multiplying log 81 base 2. Then we are dividing this by log 243 base 2, also multiplying log 16 base 2. Okay, so here we will try to reduce the values given. So the first one can be written as log 2 to the power 5 base 2. This multiplies log 3 to the power 4 base 2. And then everything here is divided by log 3 to the power 5 base 2 multiplying log 2 to the power 4 base 2. Okay, I hope you understand what we have just done. Okay, so we continue and get 5 log 2 base 2, and this is multiplying 4 log 3 base 2, which is also divided by 5 log 3 base 2 multiplying 4 log 2 base 2. So here we will have 5 multiplying 1, then multiplying 4, which is also multiplying log 3 base 2. Then this is divided by 5 log 3 base 2 multiplying 4 times 1. 5 times 4 becoming 20. And then we can also see that log 3 base 2 can cancel log 3 base 2 here. And that gives us 20 divided by another 5 by 4, which is also 20. And so the result is going to be 1 over 1, which is the same as 1. Without using tables, simplify the expression that is a fraction with numerator log 125 in brackets multiplying log 36 in brackets, and a denominator log 216 in brackets multiplying log 625 in brackets. So let's go ahead and solve. Solution. Okay, so we have log 125 in one bracket, and then we have log 36 in another bracket, and the two are multiplying as a numerator of a fraction with denominator log 216 multiplying log 625. So what we are going to do is we are going to rewrite the values so that if we can do some cancellations, we go ahead and do it. So we are going to write log 125 as log 5 to the base 3. And this is multiplying log 6 to the power 2. That is 36. Then we go ahead and then write log 216 as log 6 to the power 3. That is multiplying log 625, which can be written as log 5 to the power 4. So this is what we have. So now if we have them like this, we try and drop the exponent for each one of them. So 3 will drop, giving us 3 multiplying 2 in brackets log 5 multiplying log 6 like this. And then here 3 and 4 will also drop, giving me 3 times 4. And they are multiplying log 6 multiplying log 5. So with this, we can do some cancellations. Log 5 here cancels log 5 here. Log 6 here cancels log 6 here. 3 here cancels 3 here. And then we have 2 over 4, which can be simplified as 1 over 2 as our final answer. Without using calculator, simplify this expression, which is a fraction with numerator log 81 to the base 3 minus log 243 to the base 3 plus 8 log root of 27 to the base 3. And then the denominator of the fraction is log 81 to the base 9. So let's go ahead and then solve. Solution. Now we have log 81 to the base 3 minus log 243 to the base 3 plus log 8 log. So for the log root 27, I will rewrite it as log 27 to the power 1 over 2 and to the base 3 as the numerator, and the denominator is log 81 to the base 9. Okay, so now I'll go ahead and do the simplification, and I'll write it such that each log value will go with the base value. So log 81 can be written as log 3 to the power 4 and base 3 minus log 3 to the power 5 base 3 plus 8 log. So log 27 is the same as 3 to the power 3 and all to the power half to the base 3. And then the denominator is going to be log 9 to the power 2 base 9. Okay, so with this, I'll continue by simplifying, dropping the exponents and then applying the property that is appropriate. Okay, so have log 3 to the base 3 minus 5 log 3 to the base 3 plus 8 multiplying 3 over 2 log 3 to the base 3 with the denominator as 2 log 9 to the base 9. Okay, so what happens is if we have, let's go back to one property which we looked at, that if you have log a to the base a, then it's equal to 1. So we are going to apply that here. So the first one, we have 4 minus 5 plus, so 8 times 3 over 2 will become 12, and that is it for the numerator, and the denominator will also become 2. So when I simplify, I'll get 11 over 2 as my answer. And this, I will leave my answer as a mixed fraction instead of improper fraction. So 2 goes into 11 5 times remainder 1. So this is it.